Hello.
Hello. Yeah, good
Yeah,
evening, sir.
good evening. Uh, we had done till article number what? Article 182, I think we had done, no? Orthogonal circles.
Yes, sir. Okay. Yes,
Radical
sir.
axis and all we had
Yes,
done.
sir. Yes, sir.
Okay, so before that, exercises, doubts. Let's do some questions before we go ahead.
Yeah, so I have a doubt in examples 19, 11th question.
Hmm, one sec.
Sir, before we continue, I just want you to know that there's some network issue in my area, so I may get disconnected in the middle of the meeting.
Hmm.
So then, okay, yeah, you're recording the class. Okay, yeah, then that will not be a problem.
Yeah, yeah. Okay. What question are you saying?
11th one,
Which
exercise
exercise?
19.
Okay. 19th, 11th one. Tangents are drawn to the circle. 19, question 11. Tangents are drawn to the circle x square plus y square is equal to 12 at the points where it is met by the circle this, where it's met by the circle x square plus y square minus 5x
Plus 3y minus 2.
0. Find the point of intersection of the tangents.
Yeah,
Of intersection of the tangents. So, what is the problem? They are intersecting. Uh, what is the difficulty? Tell me.
uh,
The circles are intersecting. You have to find
yeah, we have to
tangent.
find the 10. Yeah,
This point. This is suppose x square plus y square is equal to 12, and this is the second circle.
yeah,
Tangents are drawn to this circle at these points. So this is easy if you remember some theory. In the last class, we had done something called common chord.
yeah,
Common chord equation and radical axis equation are the same actually. S1 minus S2 is 0. At the end of the last class, we had done this common chord. Radical axis generally is outside, but sometimes when it is,
yeah. S1 minus S2 is equal to 0. We did it. Yeah,
S1 minus S2 is equation of common chord. So if I find the common chord like this, right?
correct.
I can easily find common chord of the two circles because I know the equations.
Yeah,
So let's do common chord first. So x square plus y square minus 12 is equal to 0 is my second circle, right? And if I subtract, I will get what? I'll get minus 5x plus 3y minus 2 plus 12 is equal to 0, right?
yeah,
So you get minus 5x plus 3y plus 10 is equal to 0. Or basically 5x minus 3y minus 10 is equal to 0. This is my common chord equation, right?
right.
Now, obviously, you can see that this common chord is basically the chord of contact with this point for this circle. You are drawing
Yeah,
tangent
yeah,
for this common chord is also chord of contact for this point. Let's say P point is HK. What is equation of chord of contact? XH plus YK is equal to 12.
correct.
XH plus YK minus 12 is the same as this. Right?
Right,
Common chord and chord of
right.
contact are the same lines now.
Correct.
So you can compare and you can say that h by 5 is equal to k by minus 3 is equal to minus 12 by minus 10. So h is equal to 5 into 12 by 10, so 6. This is plus, so 6, and k is equal to 3 into 12, 3 into 12, 36 by 10, so it is 18 by 5.
Right.
6
Yeah.
comma 18 by 5 is my point. And how does it come? Because obviously here this is common chord and same line can be written in two ways.
Yeah, I didn't think of that part. Yeah. I didn't
What?
think of the S1 minus S2 is equal to 0.
Mhm.
So,
1 second.
yeah.
There could be a different way to do it also.
Because like when I was going through the theory, S1 minus S2 comes up in the next chapter. Like it's discussed in the next chapter. So I know we discussed it last class, but uh, it just been stuck in my mind.
Next,
Question 14.
find the condition that the chord of contact or tangents from this point should subtend a right angle at the center. We have already discussed this, dude. Chord of contact is going to subtend right angle at the center. Okay.
Oh, okay.
Uh,
I'll just refer that then.
do it now.
Yeah, okay, I can do it as well.
Chord of contact from the point x dash comma y dash. So this is my equation of chord of contact. This is going to subtend right angle at the center. Chord of contact equation is what? X dash plus
Y dash is equal to A square.
A square.
This is subtending right angle at the center. That means this OP OQ pair of straight lines is having angle between them as 90.
Yeah.
Right? So if you homogenize the circle with this chord, you should get equation of pair of straight lines OP into OQ.
Right, right.
So if you do that, then suddenly that pair of straight lines has 90-degree angle between them, right?
Right.
That is one way to do it. So one way to do it is simply just homogenize it, is equal to a square into, this is x dash plus y dash by a square whole square, right?
Yeah.
So what you will get is 1 by a square x dash plus y dash whole square is equal to x square plus y square. And now you can collect all the x square terms together. So 1 minus x dash square by a square, and that is the x square coefficient, and 1 minus y dash square by a square, that is the y square coefficient, right?
Yeah.
These are the sum should be 0 for it to show 90-degree, right?
Yeah.
This is the equation of pair of straight lines. Coefficient of x square plus coefficient of y square has to be 0. So you have x dash square plus y dash square is equal to 2a square. This is the condition that it will subtend a 90-degree, right?
Yeah.
This is question number 14, right?
Yeah.
Yeah.
1 second. So that is the answer. So you've gotten the condition. There is
Yeah.
obviously another way to do it also. This is homogenization. This we have discussed before, like 90-degree pair of straight lines.
Yeah.
And there is another way to do it also. If you know the length of the chord of contact, if you can find the length of chord of contact, then you can say Pythagoras theorem. This is
Yeah.
A, this is
Yeah.
A. So you should have 2a square is equal to this square. So job is to find the length of chord of contact, right? So how do you find that? Tell me how to find length of the chord of contact.
That's basically 1 second. And, um I don't remember the formula.
There's no formula, there's a method. Find it out. No, you
Okay,
don't have to
then.
remember everything.
Okay, yeah, just a minute, then I'll try. Um
What is this distance? Length of tangent?
uh Length of tangent is under root of that 1 sec. So basically
What is this length I want? Length of the tangent. Dave, what is happening? Pythagoras theorem, dude. What is happening? Why are you not seeing the length of the tangent?
oh yeah, we can find it using Pythagoras. Yeah, sorry. Yeah, we can, yeah.
You know this length, you know this length, you know
Yeah,
this
right.
angle.
Right, we know all three of them, yeah.
So what is this angle? Theta.
Correct.
What is sine theta? How will you write? Or cos theta?
Cos theta is basically
No,
a
don't write cos theta. What I want is basically theta angle so that I can do this tangent length into cos theta is this much.
okay. So if we have to do that, then mm, we can just simply find that, right?
Tan theta is this.
Yeah,
From tan theta, you can do cos theta.
yeah, we can go to cos theta.
You will get something for cos theta. You will do this distance into cos theta is equal to this much.
Yeah, and then we know
OP,
that thing. Yeah, we can use it from both the sides then. No, we have to use it from
OP
in the,
sine theta
yeah,
is equal to this much.
correct.
So add those two.
Yeah, yeah, understood.
No, I mean actually we don't need to do that. No, we need to
We
only
can
find
we can
this.
simply find it this way because like yeah, we know that we know the length of the tangent.
Once you know this, you can just
Yeah,
get this length.
correct. We can use Pythagoras again.
and double of that is my
Double of
chord
that.
length.
Yeah, yeah,
If you have double of that is chord length, then you get the chord length. When you get chord length, that chord length should be equal to 2a square,
correct.
because a square plus a square.
Yeah,
That is one way to do it by geometry. It is simple. You just write all the conditions.
yeah,
Sine tan theta is this, then cos theta will not be very difficult.
right.
Okay. Next one is what?
Adding in the 15th one as well. Actually, I didn't get one concept as well. It's not related to this question, but adding at the, I guess we discussed director circle last week,
Mhm.
but I didn't understand that last week when I was revising my notes. I know I think it's something we did. I don't remember it correctly, so I read through my notes, but I didn't understand.
Prove
Maybe we
that
can
the
discuss that later.
distance of 2 points P and Q, each from the polar of the other with respect to a circle, each from the polar of the other with respect to a circle, are to one another as the distances of the points from the center. Basically, are in the ratio of the distances of P and Q from center of the circle.
Hello.
Hmm.
Yes, sir. Sorry, I got disconnected. Did we do anything new?
We did question 14.
Oh, okay. Yeah, that I got. Okay.
So distance of point P from polar of Q, is 2. Distance of point Q from polar of P is equal to OP is to OQ. You have to prove this. This is fairly straightforward. No, take any circle, you can just do it. Let P be x1 comma y1, Q be x2 comma y2. Do it now. Do all of this, find out the distances.
Yeah, 1 minute. Let's do it. Yeah, so 1 becomes x1 plus x2. Mm, so uh, proof.
It is super obvious.
Yeah, I got it. We have to just find it for both of them, and then we have to divide both of them, and then we have to. It comes out to be this thing. It basically comes out to be equal to uh, PC by QC. C is the center. Yeah, got it. Yeah.
So this question is just simply basically understanding what he's asking.
Yeah. I was
Distances are in the ratio. That is what he means.
I was getting the inverse ratio. So when I solved it, so
Then next.
17.
Tangents are drawn from HK to the circle. Prove that the area of triangle found by them and the
Okay,
straight
actually,
line.
I think I can do this. It's not that hard.
Obviously this is the same thing again.
Yeah, it's the same thing. Okay, then this is the last one, 22. 22. Yeah, 22.
Yes, sir. I have a doubt in the same question.
First, the 17th one, what will you do? Think about it and do it. 1 second.
Yeah.
1 second. So you have to find area of this triangle.
Correct. So, uh,
Area of triangle PQR. So how will you do it? Hello?
yeah, so sorry.
How will you do this? Area of triangle PQR.
Yeah, so basically what we can do is we know that the equation of the given circle is x square plus y square is equal to a square. So then we can assume a point. No, we are given a point h comma k
Hmm.
from where the tangents are drawn.
Hmm.
So then we can basically uh, then uh, we can find the length of the chord of contact.
Mm-hmm.
We have to first find the equation of the chord of contact, and
That is known.
yeah, that's known. And then we can find the basic. We can find that equation of tangent once again.
Which equation of tangent?
Uh, like PQ.
Why will you find equation of tangent?
No, I
How
mean
do you know the
length. I
equation of
mean length.
tangent?
I mean length. My bad. Length. I meant.
What is the length?
So basically, we know the equation of the chord of contact. So it becomes. Uh,
What is the length of tangent?
yeah, we have to use Pythagoras theorem again.
So what
So
is it?
h square plus k square minus a square.
And this?
It'll be the same thing.
Okay. Then
Then what we have to do is, after we get this, um, area of the triangle formed by them and the straight line joining their points. Okay, so now we can again find the length of the chord. No, we have to basically do the same thing. So what we have to do now is we have to find the same length we found in the previous question, and
you
and then
don't
we
have to find the length of chord of contact. Why would you do that? You do half BC sine this.
okay, yeah, we can do that as well. And yeah, right. I was making it complicated. Yeah, we can do that, right?
Given tan theta is equal to A by this, You can find sine 2 theta. Tan theta is this, that perpendicular is this, base is this. Cos theta is equal to base by hypotenuse. By hypotenuse is this.
Correct.
Sine theta is equal to perpendicular by hypotenuse. So a by root over h square plus k square. So sine 2
Yeah.
theta is simply 2 will get cancelled. It is h square plus k square minus a square into sine theta cos theta, which is a into root over h square plus k square minus a square by h square plus k square. That is the area of the triangle.
Yeah.
This is
Yeah.
fairly
Yeah.
straightforward stuff.
Yeah. I didn't, because like I couldn't think of the previous question, so I didn't get this one as well. Yeah. Right. I got it. Like I understood now how to do it.
You have to use your properties of triangles, dude. You cannot be to like, hey, this is a circle question, so I have to not use anything else.
Correct. Yeah. I just went out of my mind.
Question 22, what is the problem?
In 22, so basically he's saying the distance from the origin of the center of the three circles. This where he's
Minus 2 lambda x is equal to c square. Center of the three circles. Lambda is a variable, c is a constant. Are in geometric progression. Distances of centers from the origin
I
are
can't.
in
I'm not able to visualize the question. So
length of tangent drawn to them from any point on the circle. These are also in G. Prove that what does he mean that there are three circles? What should it mean? This is an equation of a circle. Is this a circle equation? Hello?
sorry, sir, I was on mute. Yeah, it is a circle equation.
So what is the center of this circle?
Center of the circle is lambda and 0.
Radius is what?
Lambda square under root lambda square plus c square. No. Yeah.
So why is he saying three circles? Then what will he mean then?
I think he means that the lambda point's variable. That's why we can have three circles. Or c is also variable. No, c is a constant, so lambda varies. So that is why we have three circles. Yeah.
Yeah.
C is a constant. There are three circles like this. And distance of the centers from the origin means what? Basically, lambda 1, lambda 2, lambda 3 are in GP.
Right.
What is he saying? Distance of the centers of those three circles are in GP. What is distance from the center to the origin? Lambda 1. You have lambda 1, lambda 2, lambda 3 are in GP is given. So now you have to say length of tangent drawn to them from any point on this circle. Any point on this circle can be written as what? Any point on this circle can be written as What is a general description of a point on that circle? We have done parametric form and all last week. What is the general description of any point on that circle?
R and theta. R.
R and theta is a general description of any point, not a point on a circle.
Oh, okay. And also, okay, yeah, one.
C cos theta comma C sine theta.
Yeah, I meant R cos theta. And, yeah, we can we say R cos theta and R sin theta? Yeah, we can, right?
That is not R theta. You
Yeah,
have to
I
say
meant
C
like
cos
I
theta.
meant like in the form of R and theta. I didn't mean R theta literally. Yeah, I wasn't
So
clear.
from here, length of tangent is what to this circle? What is the length of tangent from this point P to this circle? Suppose it was lambda 1. How do you find length of tangent from any point to any circle? Circle equation is given, point is given.
We have to do the same thing we did before, right?
What same thing?
The one we've been doing in previous questions.
Do a different thing.
Okay. 1 second, then let me just think.
Last week we had done theory of this, how to find length of tangent from any point to any circle.
Uh,
This is article number 168, dude. How have you forgotten?
uh, okay. Yeah, I don't exactly remember the article, but
Open the book and see.
yeah, I can open the book and 168. Just a second. Yeah. Okay. Yeah. Oh, yeah. Right. We did this. Yeah.
Length of tangent from any point to any circle is just by substituting that point in that circle.
Correct.
If my circle is lambda 1, my length of tangent 1 will be equal to root over, put this point in this, so it will become c square minus 2 lambda c cos lambda 1 c cos theta minus c square. So just simply becomes this. Length 2 will become c square minus 2 lambda 2 c cos theta minus c square. And length 3 will also become minus 2 lambda 3 c cos theta. So obviously these are all constants, and lambda 1, lambda 2, lambda 3 are in AP. So GP. So this is also in GP, root of that. If you take ratio of L1 is to L2 is to L3, minus 2 cos theta, root of that disappears. See, everything goes away. It's just root of lambda 1 is to root of lambda 2 is to root of lambda 3. If lambda 1, lambda 2, lambda 3 are in GP, this is also a GP.
Yeah. Right. Got it.
2, 4, 8 are in GP, then root 2, 2 and 2 root 2 are also in GP, no?
Yeah, they are.
This is about just simply just doing the stuff. Like, if you are stuck on a question, you have to go back to the theory and find out what you have been stuck on. No, you cannot be like, "Hey, I have not," you cannot be like, "I have a problem in this question and I will not look at it in the theory. I will not try to find it in the theory. I'll wait for me to explain." Why didn't you, when you had this question, there's nothing very, if you had understood that he means lambda 1, lambda 2, lambda 3,
Yeah,
after that,
I didn't get that.
you got it. I asked you, you said this is that.
I understood after you wrote it down. I told it like when we were reading the question, I told you that I wasn't able to visualize the question.
You cannot forget the theory, dude, is the point basically. And if you are coming to the next week's class, you have to figure out the questions. If you're doing some exercise, you have to go back to the theory and see if you can use something and get the answer, not give up immediately. What is the
Yeah,
next doubt?
I don't have anything from this exercise.
Next exercise.
Um, I have doubt in example 21, seventh and sixth and seventh question.
21, I told you to not do, no?
Oh, okay, I didn't know. Okay, it's fine.
How are you doing questions where the angles are inclined, dude? Like axis is inclined at 45 degree and 60 degree, you know?
I read through the theory in the book.
Why?
Like, look, I thought we had to do them as well.
Have I not marked 3 times or 2 times? I've told you that these things are not supposed to be done. These articles are excluded. In the class, I've told you, like, why are you wasting your time with unnecessary stuff? When did I
Ye-
teach 175, dude? 175, 176.
Yeah, we didn't discuss that.
So now you're doing exercise 21.
Yeah, but I did only like 4 questions, 5 questions, so it's fine. They took me like 5 minutes.
Okay, great.
Yeah, so we can move on to the locus exercise then.
Exercise 22.
Yeah, I have a doubt in the fifth question and the fourth one.
And first, second, third is done.
Yeah, first, second, third's easy.
Find the locus of a point which moves so that the square of the tangent drawn from it to the circle is equal to c times its distance from the straight line. Point moves so that the square of tangent drawn from it. What is the problem? PHK is a variable point. Square of tangent drawn from it to the circle. Again, you don't know how to find length of tangent, no?
Yeah.
And when you saw this question, then you didn't bother to find out what is square of tangent from a point to a circle.
No, I mean I looked on to the formula, but
What looked onto what formula?
the formula which is given in that article. I mean, I didn't remember. I didn't remember the formula. I didn't remember the article number. I just scrolled back through the book to find the formula. So that is why I didn't like. I don't remember the formula.
Fine, then if you scrolled back and found the formula, then the question is immediately solved. No, square of tangent is equal to c times its distance from a straight line. What is the big deal in distance from a straight line?
Yeah, I know the. Okay, yeah, right. Okay, fine. Yeah,
What is now
yeah,
left in the question? That's it. Square. This is already a circle, by the way. Coefficient of x and y are same and no xy term is
right,
there.
right. Yeah, I got confused in the variables. Like I think I was have I don't. Yeah, I got confused in variables.
You have to read the question carefully and see what is happening. Like this is clearly length of tangent and square of that is this, and distance, it's clearly mentioned distance from this point to this line.
Yeah.
There's nothing else. It's directly locus is coming. C by root L square plus M square into Lx plus My plus N. This is obvious. Already it is a circle. You don't even have to simplify.
Yeah.
Then fifth one. Find the locus of a point whose distance from a fixed point is in a constant ratio to the tangent drawn from it to a given circle. Do it now. Again,
Yeah.
it's the same thing.
Hmm.
Question 5 is again same thing. Do it now.
Yeah, I'll do it. I'm doing it. Yeah, got it.
What did you get?
So basically, I assume the equation of the circle to be x square plus y square is equal to a square.
Hmm.
So then I consider the point p h comma k, which is the variable point.
Mm-hmm.
And then what I did was, so basically I found the length of pt, basically the tangent, which is basically under root of h square plus k square minus a square.
Mm-hmm.
Then what I did was I assumed the point q. Basically, I had to assume another point which was fixed.
Mm.
So I assume that point to be a comma b.
Whatever.
Yeah, same thing. Then okay, I shouldn't have assumed it a comma b.
Mm.
Then basically, then I found the length of PQ
Ratio to the tangent.
because we had to find that ratio. So I found the length of PQ and then I equated it to gamma, basically a constant. And then basically just solve this now. Like take the denominator to the other side and square both the sides. And
This
then
will be a circle because there will be
yeah,
no
it has to
xy
be.
terms.
Yeah, and it'll be in the form of it'll have lambda and gamma in it.
Coefficient of h square and k square will be same, and there will be no xy term, right?
Yeah.
It will be this type of thing: lambda square into h minus x naught square plus k minus y naught square. So h square coefficient will be lambda square minus 1, and y square coefficient will also be lambda square minus 1. And there will be no other hk terms. So this is a circle. Okay, whichever. What is next then?
Yeah, 1 second. So how about out in question number 9?
8 is done.
Yeah.
Locus of
I
intersection of lines.
yeah.
Okay. Question 9. Point P on a circle, perpendiculars PM and PN.
In the
And
eighth one, I just squared both of them and added them. I think that should be correct.
how is that correct, dude? You have to first solve it, no?
Yeah, I mean, assuming point h comma k to be the intersection, and
Hmm.
then basically we basically get the same thing in the end, even if we do it this way. But of course, that's not the right way. This is not the right way to do it.
No, if you assume h comma k is the intersection, then you can put h and k in both the equations and then eliminate alpha by squaring and adding.
Yeah.
That's right. There's nothing wrong with that.
Yeah.
But you have to say that you have to assume hk,
Yeah.
which is on both the lines. If you just
Yeah.
square and add, that doesn't make any sense.
Correct. 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 Yeah, I took h comma k and did it.
From a point P on a circle, perpendiculars PM and PN are drawn to two radii of the circles. Find the locus of middle point of MN. Okay. There is a circle. One radius is like this, one radius is like this. From a point P on a circle, perpendicular PM and PN are drawn. Find the locus of middle point of MN. Middle point of MN locus. Okay. Uh, Fine. Okay. So what have you guys tried here?
I couldn't think of anything.
Hmm. So this is a question which basically depends on the angle between the two radii. If this thing angle is theta, this point is P, you drop this perpendicular and this perpendicular, N and M. This is O. So midpoint of Mn you need to find, locus of midpoint. So if this angle is theta, this angle will be 180 minus theta. minus theta, and this is an angular axis question. So axis is that line OM and ON, they are having theta angle between them, right? So
Yeah.
you can
Yeah.
say that OP is the radius, and in triangle OAP, in triangle ONP, in triangle ONP, you can do cosine rule. You can do OP square is equal to OP square is equal to ON square plus NP square minus 2ON OP minus 1 second. This is right angle triangle. No? So you have ON square is equal to OP ON square plus OP square is equal to P square. Yeah. But okay, then I should do it in some other triangle. Okay. First of all, this question you can actually ignore because of this angular axis. But if you
Okay, it
want
was
to
of
do
that
it,
20 exercise.
uh,
Okay.
if you want to do it, then you have to think of P here,
We can.
M, N, take parallel lines like this, A, and parallel lines B. Now OP. If this angle is theta, this whole angle is 180 minus theta. This whole angle is 180 minus theta. And in this triangle, what are all my angles? If this is theta, this is also theta because parallel lines. So this is theta, this is 180 minus theta. This should be theta, right? No. If this is theta, this is 180 minus theta, so this is theta, right? That doesn't make any sense. 180 minus theta, this should be. Correct. 180 minus theta, no? Makes sense. Because this is theta and this is a parallelogram that I have drawn.
Right, right.
So OPB, in triangle OPB, you can say cos of 180 minus theta is equal to OB square plus BP square minus OP square by 2OB into BP. This is minus cos theta. So you get minus 2OB BP cos theta. So you get OP square is equal to OB square plus BP square plus 2OB into BP cos theta. This goes this side, this comes this side. Correct. Now, OP square is equal to A square, and okay. And if you draw a parallelogram like this, then this point P, suppose H comma K, I think you have to use some angular axis stuff here. So I don't think we should do this. This is not. I don't think it will come without using that angular axis circle equation or not. So I don't think we should worry about this one. Ninth one you can skip.
Okay.
Okay, because the problem is that if this was like this, then it was an easy question. But the angular axis is what is making it a slightly annoying one. So you can skip this ninth one. Then next. Tenth one has been done. Tenth one is important.
So I solved only till the 8th one.
Do 10th one then.
Yeah, sure, sir.
Question 10.
Yeah, I didn't get the 11th and the 12th and the 10th one.
Try 10th one. Tangents are drawn to a circle from a point which always lies on a given line. Tangents are drawn to a circle from a point which always lies on a given line. Given line. Prove that locus of middle point of the chord of contact is another circle.
Okay, so um, the variable point in our case would be the middle point of the chord.
Hmm.
Okay.
Okay. Take a given line and a given circle. Let's say my line is this. Let's say my circle is this. This is a given line and a given circle. Now, let's suppose any point alpha comma beta on this line. Suppose.
So can you just give 2 minutes? I'm trying it.
Hmm.
Yeah.
Yes, sir, even I'm trying.
What happened?
Yes, sir. Give me a minute. I guess I almost got it.
I got it, sir.
How?
We can assume the line to be okay. I assumed it's something different, but yeah, it can be x plus by plus c. Yeah, and after this, what we have to do is basically alpha comma beta is basically a point on the straight line ax plus by plus c.
Mm-hmm.
So we can write it as a alpha plus b beta plus c is equal to 0. Also, um, we can write the chord of contact uh, equation, so that yeah, it becomes this y beta is equal to r square. And then we know that h comma k is the mid, like basically p is the midpoint, so we can assume p to be h comma k.
Mm-hmm.
So h comma k should satisfy this equation, the chord of contact equation. So yeah, it becomes this. And now what we have to do is, uh, one second. I think I made some mistake here. Just a minute. Uh, yeah, so just a minute. I think I made a mistake here.
Mm-hmm.
Uh, yeah, so what we can do is we can basically draw.
Hello? Hello?
Yeah, our origin will be 0 comma 0 because that's according to the equation we assumed. So we can basically draw perpendicular line from the origin to the basically the straight line,
Which straight line?
ax plus by plus c.
How does that help?
Uh, oh, no, I mean through the
That
point
is not
P.
necessary. That is
Okay,
not
yeah,
possible.
we can do this as well, right?
You can say you can draw a line through the origin perpendicular to the chord of contact that will pass through the middle point.
Yeah, then we can also then that means we can find the equation of that as well, because we
Perpendicular to chord of
yeah
contact will be slope will be beta by alpha.
yeah so yeah beta by alpha.
H comma k will lie on it.
Correct. H comma k will and then we can basically now solve the equations.
You can solve this and this
And
together.
then we can get the values of alpha and beta because those are assumed variables and we have to eliminate them. So we can use them and find the value of alpha comma beta, and then we can use the values of alpha comma beta in the linear equation, like the terms which have h and k in them, and then we can replace h and k finally with yeah with x and y to get the answer.
You will get this alpha and beta.
Yeah,
So
I got something like this.
now you can put that in this one. A alpha plus B beta plus C is 0. So you will get, in terms of hk and h square plus k square, you will get a circle equation. You can substitute this alpha and this beta into this original equation.
Yeah.
So that will remove alpha beta and get it in terms of HKR
Yeah.
at the given line ABC.
Yeah.
That is a circle equation,
Correct.
but it will not come if you don't solve for HK. So you have to have
Yeah,
one
we
more
have to
conditional.
solve. Yeah, because alpha comma beta is an assumed variable.
So how did you solve for HK?
I just put the values.
You have to have a second equation. No, what was your second equation? This
My
is the
second,
uh,
the h comma k on the circle, right? Okay, no, that is one. And the other equation was just a second. I'll have to look through. It's kind of messed up. Uh,
midpoint of the chord of contact is HK. That one
yeah, yeah,
condition you
yeah.
get. What is the second condition?
We found the no, so we have two equations, right? One of
We
them is
don't have two equations. We have two variables H and K, but only one equation.
no. I mean, we okay, right. Yeah. So wait, then one second. No, so we have one equation that is uh basically beta h minus alpha k, right? Is equal to
That
0.
is
So
that
we
equation is I have told. What were you doing?
no, I wrote the same equation that because that because point P should lie on the chord of contact.
P should lie on chord of contact. That is this equation, dude.
Oh, right.
How is this equation coming from P should lie on chord of?
Okay, then I didn't get it till the end.
P
Okay.
should. This is chord of contact equation. No.
Yeah.
P lies on chord of contact is this equation.
Yeah, that's there. Uh,
What is your you? If you don't have a second equation, you cannot solve for alpha beta.
okay. So I didn't actually solve it completely. I just got till the ending of it. Just a second. If I just see it.
The only other condition that you can use here is that P is midpoint of a chord, so it lies on a line perpendicular to chord of contact,
Perpendicular to,
passing
yeah,
through the center.
yeah, from that we got that equation.
So passing through the center, if you draw a line which is perpendicular to a chord of contact, perpendicular, that is this, and P will lie on it. So HK will come in terms of this.
Hmm. Hmm.
Now you have HK, you have two equations involving HK. So you can
Yeah.
solve for, or alpha beta also, you can eliminate alpha beta by
Yeah.
solving for alpha beta.
Right.
If you don't have the second equation, you cannot do anything.
Yeah. Okay, I was solving it with only one equation. We couldn't solve anything with one actually. I don't know what I was doing.
Dave,
Hello.
hello. Have you seen this solution or have you missed it?
Sir, I missed it and I could not solve this question. Can you please explain how we should do this?
So first, there was a line ax plus by plus c which is given. There was a circle that is given, right?
Yeah. Yeah.
Alpha beta can be any point on the line. So let's say alpha beta is a random point on the line. So one condition you have is a alpha plus b beta plus c is equal to 0, right?
Yes.
Now from this point alpha beta, you're drawing two tangents. So
Correct.
two tangents and those chord of contact you are making, right?
Yeah.
So chord of contact you are making. Then so my chord of contact equation will be x alpha plus y beta is equal to r square.
Correct.
You have to find locus of middle point of chord of contact. So let that middle point be P h comma k. So P h comma k will lie on chord of contact.
Yes, it will.
So you'll get h alpha plus k beta is equal to r square. But that is just the second equation that you have got. Now this hk, there are two unknowns. You need one more equation to solve for hk or something. There are right now too many unknowns. So you need one more condition. If you have one more condition, you can solve for alpha comma beta here.
Yeah.
So how will we do that? We have one fact that midpoint of the chord of contact midpoint, you can join it to the center. That line should be perpendicular to the chord of contact, right?
Oh, yeah, correct.
Midpoint, basically line joining center to the midpoint of the chord of contact should be perpendicular to it. That is the property. So what we are using here is y minus 0 is a line through the origin, and slope of that line is beta by alpha, because slope of the chord of contact is minus alpha by beta, right?
Right.
So this line is a line that passes through chord of contact, right? Midpoint of the chord of contact.
Yeah.
So h comma k will lie on this. So you get k is equal to beta by alpha x h, right?
Yes, correct.
K is equal to beta by alpha into h. No, I can't hear you, dude. Aditya. So now you have k is equal to beta by alpha h and this equation also. So these two equations now you can solve for alpha and beta. So you can just do alpha is equal to beta by k into h and substitute that.
Yeah.
In
Okay.
this you'll get beta is equal to this and alpha is equal to this. Once you know alpha and beta in terms of my h and k, I can put that in this, right?
Correct.
If you put that in this, you will get a equation which is in terms of h and k and r, right? And also the
Yeah.
constants a, b, and c. So everything is known in that. The only variables are h, k, and r.
Okay. Now I can do it. Okay.
The point is basically that the chord of contact, you have midpoint lies on chord of contact, hk lies on chord of contact. That is fine, but that is not enough. What is it? You also need the fact that this is perpendicular, right? 0, 0 to hk, the
Correct.
slope is going to be perpendicular to this slope, right?
Yeah.
If you
Yeah.
have that also, then you'll be able to solve for hk and all.
Correct. Yeah.
So that is how you get it. Uh, so then once
Yes,
you
sir.
solve
Understood.
it, you'll put that in the original stuff and you'll get it.
Yes. Okay.
Question 11. Question 11 is find the locus of middle points of the chords of the circle. Locus of midpoints of the chords of the circle. X square plus y square is equal to a square, which pass through a fixed point h comma k, which pass through a fixed point h comma k. Locus of middle points of chord of a circle. So okay, try this. What is the approach? What are you guys trying? Again, take the middle point locus that you want. Take it as alpha, beta. In this case, hk is already taken. So this middle point is this alpha, beta. Middle points of chords of the circle which pass through a fixed point. So any line through this point, any line through this fixed point, basically any chord, can be written as y minus k is equal to m times x minus h, right? So therefore you have alpha beta must pass through this. So you should have beta minus k is equal to m times alpha minus h. This is your first equation. Now the same logic, any line perpendicular to this chord, right? No, not to this thing. Any line, correct. Any line perpendicular to this chord and passing through the center will be what? Y minus 0 is equal to minus 1 by m x minus 0. Line through center perpendicular to chord. Perpendicular to chord. Correct? So you have
Yes, yes.
my plus x is equal to 0. And since alpha beta midpoint will lie on this also, so you have m beta plus alpha is equal to 0. Therefore alpha is equal to minus m beta, right? This is your second equation, and
Correct. Yeah.
now you can directly try to get it by removing m. M is equal to minus alpha by beta and substitute that in the first equation. So you get beta minus k is equal to minus alpha by beta alpha minus h. So you get beta square minus k beta is equal to minus alpha square plus alpha h. Therefore, the equation becomes alpha square plus beta square minus alpha h minus beta k is equal to 0. This is clearly a circle equation is if alpha beta is varying, right? This is the equation of a circle.
Yes, correct.
This becomes circle is this. So whenever you have midpoint of a chord type of a question, you should think of a line from the center which is perpendicular to the chord will also pass through that midpoint. That is an important property that helps us solve many questions here. One standard equation anybody can write, the chord equation, basic equation of a chord somehow. And after that, if you also add in the property that the midpoint of the chord will pass through the perpendicular from the center, then you have enough information to solve for that midpoint or eliminate unnecessary variables. That is how you do it. Question 11.
Yes, I got it.
Question 12. Try question 12 now yourself. It is again same thing, just the condition is different now.
I tried question 12 once, running get it at the first go.
Try it now.
Yeah. Is there any specific location you have to consider for the point c comma 0?
Location is c comma 0. No?
I mean, like within the circle or outside the circle.
No, that is it's a general question. No, you cannot assume anything.
So we can assume it to be on the circle, or we have to like.
How will you assume that, dude? It's not said that c is comma 0 lies on the circle. No?
Okay, yeah. But then it even doesn't say like it'll lie outside or okay, yeah, fine.
Locus of midpoints of chords which subtend 90 degree at c comma 0. So first you have to construct the chord. So you take 2 points A and B on the circle, and the points can be written as A cos alpha, A sin alpha, and this can be written as A cos beta, A sin beta. These are my A and B. Then P is the middle point of this. So P is basically A by 2 cos alpha plus cos beta, A by 2 sin alpha plus sin beta. This is my P, right? So now Q is the given point C comma 0. Then chord is subtending, some chord is subtending 90 degree at some point. So A is this, B is this, and this point is Q, C comma 0. Then obviously slope of this and slope of this are perpendicular. So you have slope of AQ. AQ slope is equal to A sin alpha by A cos alpha minus C, and similarly BQ slope. BQ slope is basically A sin beta by A cos beta minus C. So AQ slope into BQ slope should be -1, right? You get A square sin alpha sin beta equal to minus of A cos alpha minus C and A cos beta minus C. So this becomes minus A square cos alpha cos beta uh, minus A square cos alpha cos beta and minus AC cos alpha, so becomes a minus AC cos alpha, so plus AC cos alpha plus AC cos beta plus C square, so minus C square is equal to A square sin alpha sin beta. So what we are getting is A square common, sin alpha sin beta plus cos alpha cos beta. So sin alpha plus cos alpha cos beta common minus AC cos alpha plus cos beta plus C square is equal to 0. So this is one equation. So we have three equations actually. We have H, K, and this is H, this is K, and we have this one also. So I will just write all of them on top. H was equal to A by 2 cos alpha plus cos beta. K was equal to A by 2 And the third equation that we got was a square sine alpha sine beta plus cos alpha cos beta is equal to minus AC cos alpha plus cos beta plus c square is equal to 0. Now, so if you square and add to this 2, so you'll get h square plus k square is equal to a square by 4 cos square plus sine square 1 plus cos square plus sine square 1. So 2 plus 2 times cos alpha cos beta this is equal to h square plus k square.
Yeah, yeah,
So now we get an expression for basically cos alpha cos beta plus sine alpha sine beta from here
right.
is equal to 4 times h square plus k square by a square minus 2 by 2. So minus 1 and this becomes 2. 2 times h square plus k square minus a square by a square. So this we already have now. And cos alpha plus cos beta is equal to 2h by a.
Yeah,
So now you can just simply substitute in this equation, no?
correct. Yeah, we can.
So it becomes a square into 2 times h square plus k square minus a square by a square minus ac into 2h by a plus c square is equal to 0. So this becomes, this cancels 2h square plus k square is 2k square minus 2a square minus 2a square, no, minus a square only, and plus, okay, minus 2hc is there. Plus c square minus a square
Right.
is equal to 0. This is the equation of the locus. Nothing much I have done. I've just written hk and I have written this equation. This is just the slope condition basically.
Yeah,
And after that, I'm just trying to simplify it somehow. So I'm getting cos alpha, cos beta, and sin alpha, sin beta to eliminate this part. By doing squaring and adding, I can get this. And after that, it is just about putting it back in this.
yeah.
Okay. Question 12th was this. Question 13.
Yes, I got it.
Okay.
Question 13, I got it. After that, I got an attempt.
Question. Okay, tell me. Try to do maybe question number 15. Question 15, yeah. Try to think of question 15. Make some simplifying assumptions if you can. One vertex of a given triangle of a given species is fixed and another moves along the circumference of a fixed circle. Prove that the locus of the remaining vertex is a circle, find its center, find its radius, right? So we can take a triangle. The hint is take a triangle OAP where one vertex is origin or center of the circle. center of the no, it cannot be center of the circle. It is just origin,
Yes.
and
Okay, origin, right.
and A is any point on the circumference of a circle. On the circumference of a circle, you have to find locus of P. Yeah.
Right, right. Yes, I'll try.
So suppose there is a circle This is suppose origin O, center of the circle is C, and P is some point on the circumference. A is any point on the circumference and P is a variable point, right? A is any point on the
Yes, sir.
circumference
Yes,
of
sir.
the circle. So
Correct.
A is here and P is a moving point, arbitrary point. So let's work in polar coordinates. So what you can say is polar coordinates of the center you can take as d comma theta uh, d comma theta you can take theta naught, and this will be a can be taken as r1 theta 1 and p is my variable point anywhere r comma theta. So angles, if this triangle is there, angle POA will be theta 1 minus theta, and OAP and OPA. Okay. So also this AOC, this angle is basically theta 1 minus theta naught, right?
Yes.
So you can say this is a circle, this is radius of the circle. This is, say, let's say radius is A. So you can do cosine rule now in this triangle, and r1 is any variable point on this. Okay, cosine rule in this triangle, and you can do cosine rule here also. Either cosine rule or sine rule, you have to eliminate some stuff, right? So let's think about it. One relation that you have is AC square is equal to OA square plus OC square
Yes,
minus
correct.
2OA OC
2A OC.
cos of this angle, cos of theta 1 minus theta 0, right? The other relation is
Yes.
uh, the other relation is so OA square and OC square and all can be written as AC square is what? AC square is simply A square. OA square is R1 square. OC square is some distance D square minus 2 R1 D cos of theta 1 minus theta 0. This is one relation we have. And in triangle OAP, what we can say is sine rule, we have OA by sine of this angle, this angle will be what? Can we figure that out? Okay, let's call it something. Let's call it OAP only. OPA is equal to OP, OP by sine of this angle, which is sine of OAP, right? So we have OA distance is called R1. R1 by sine angle OPA is equal to OP. OP distance is called R. R is equal to R1 sine OPA by sine OAP. We have this, and correct, this is coming, no? So we also have
Yeah, it is.
AOC angle. Angle AOC angle is equal to angle POC minus, or angle POA minus POC. POA minus angle POC, right? AOC angle. So basically,
Yeah,
theta 1 minus theta naught is AOC is equal to POA. POA is theta 1 minus theta minus POC. POC is theta minus theta naught, right?
yes.
So you should get a condition on theta also from here. You'll get theta 1 will cancel, and this will become minus 2 theta plus theta naught.
I guess we took POC wrong.
Basically, make sure the signs are correct. I just want to write it properly. So this big angle minus this angle is
Yeah.
equal to so AOC I want to write. So that should be equal to AOP minus COP, right?
Yeah.
AOC is equal to AOP minus COP. So
Oh,
AOP is what? AOP is theta 1 minus theta, right?
yeah.
Theta 1 minus theta minus
Correct.
COP is theta minus theta
It's
naught.
see.
COP is theta naught minus theta.
Yeah, we messed up the sign there.
But that is eliminating my theta that I don't want.
No, I guess that should be theta 1, right?
Which one will be theta 1?
Theta naught minus theta 1. 1 second. COP is
No, it is theta only.
th-
I mean, that is eliminating my theta. So what I can do is I can just write theta 1 minus theta naught in terms of theta 1 minus theta naught minus theta, no?
yeah, we can do that.
Correct.
Yeah.
Yeah.
Right. So you'll get an equation in terms of these angles. Theta 1 minus theta is a known angle, this angle. And theta naught minus theta is a known angle. Theta naught minus theta naught is this angle, right? You'll get cos C minus D, right? Something like that, right? Correct.
Yes.
And this cos C minus D can be written as cos plus sin and stuff, right? What I want to do is
Correct.
get an equation for r comma theta. So r comma theta you will get only if you have those terms in this equation, no? So you can even just, as long as you can eliminate your theta 1 and all, you can leave the rest. This is slightly complicated. Maybe we'll have to draw a better figure and do it. Try it once. Slightly complicated because of the polar coordinate stuff.
Right.
Yeah.
Draw a better figure maybe and try it once more. Sine rule and cosine rule are the only ways you can do it. So
Yeah.
just try it once more.
Yeah.
Sure, sir.
Try these remaining questions also you should try, except for any questions where there is angular coordinates and all.
Okay.
Except for those you can try whatever and revise till the radical axis stuff that we had done. Next class we'll finish the chapter. So next class is the last class for circles. So
Yeah.
make sure that you solve enough problems and have the doubts and all that you can fix by
Yeah.
next week. Next week is definitely last class of circles. After that, what we'll start is complex numbers.
Yeah.
Sure, sir. Okay.
Complex numbers we'll do after circles, and we'll probably also do binomial theorem. Binomial theorem, complex numbers, PNC. These chapters we'll do, and then we'll do parabola, ellipse, hyperbola.
Hmm.
Okay.
So that is the sequence. Once these are done, then your 11th standard, these are the 4 chapters that are left for you in 11th standard.
Oh,
So
okay.
then we'll start 12th standard, that will be calculus will start.
12th has only calculus, majorly,
Mostly calculus, 1 or 2
and
chapters in
probability
algebra.
and all that, right? Stat probability and
Vectors, 3D and algebra is some 2-3 chapters.
yeah.
There is algebra, there are 2-3 chapters, determinants, matrices, probability.
Hmm.
And vectors and 3D are 2 chapters, and then rest of it is calculus.
Oh,
So we have
okay.
to finish these we have to finish in maybe like 2 months or so, 2-3 months.
Yeah.
Yeah.
Okay.
Okay.
That's it for now.
Okay. Thank you, sir.
Bye.
Thank you, sir.
Bye. Sir,
Uh.
we also got our marks.
Uh-huh. Which test?
So, Allen test.
When was this?
This was last week. This was last Wednesday.
This
This
Wednesday.
Wednesday.
Yeah, this Wednesday. I meant that.
How much did you get?
I got 278.
278.
Yes.
What chapter was this, dude?
So there were quite easy chapters. There were solutions of triangles and only the introductory part of straight lines, and then there was in chemistry there was gaseous state which we had done, and in physics there was work par energy and circular motion.
So
So
what
it was
is the
quite
rank?
easy.
In the
Sir,
center?
I didn't get they haven't told us the class rank. Like it's not coming for me, but I guess in the rank in the state rank, I got 44. I'm not
In
state rank, but
South Zone.
yeah, South Zone.
Aditya, how much did you get?
I scored 266.
And your South Zone rank?
90.
Okay, that's good only.
Yeah.
Yeah, but these are easy, dude. This doesn't matter so much.
Yeah.
What is important is going ahead in the syllabus so that you are always ahead.
Yeah.
So keep
Yes, sir.
keep doing what is assigned, the homework and all. Tomorrow we'll do physics. Okay, so work through the HCV questions. We'll try and finish the last 10-15 questions that are there.
Yeah.
Yeah, sure, sir.
Okay, bye.
Okay,
Bye.
thank you, sir. Bye.